Hey there, Year 12s. We're now looking at, in the previous video, I mentioned that you can do regular payments like this using the recursive model and then find the amount in, say, 12 months or after 12 payments. The problem is that you don't want to be pressing enter too many times. Say if I want to know after 99 payments, you don't want to be doing 99 enters. There has to be a quicker way. So in this example here, we're going to now use Finance Solver to see how we would calculate when we want to find many months ahead, or we want to calculate payments that are very huge. Okay, so here we go. Let's have a look at this one. They say that Lars invests $500,000 at 5.5% per annum. So compounding monthly. So in this case here, we can say invest his money, so it means that they gain money. He makes a regular deposit of $500 per month into the account. So what is the value of his investment after 5 years? This is cool. All right, so we're starting off with V0 is equal to $500,000. Okay, so think of this is Lars, and he's putting into the bank account $500,000. Just do 500K. Okay, so that means that's money out of his pocket into the bank. So we know it's going to be negative there if we're using Finance Solver, right? And then on top of that, we also know that there's a compounding per annum, 5.5% per annum, compounding monthly. So when you see compounding monthly, this is where it affects your PPY and CPY. So payments per year and compounding payments per year. In our case, because you're compounding monthly, how many payments would you make per year? Well, it has to be 12, okay? And then obviously 5.5% is your rate. So R, which is in per annum, is 5.5 already when you're using Finance Solver. Okay, and V0 is obviously your the amount that you start off with, which is PV for present value. And then he makes a regular deposit. So remember, this is extra money from his pocket into the account. So again, that's a minus $500 there that they're putting additional per month into the account. So let's have a look, and that's your PMT. That's PMT, your payments, in our case, would be negative 500 every month. So when I use my Finance Solver, right, I'm going to just show you here. Grab my Finance Solver menu, number 8, 1, and let's just delete all of these that we had. I'm just going to delete them all. Okay, cool. So going all the way back to N, they said N was 5 years. So if N was equal to 5 years, but remember 5 years, we're compounding monthly. So that means each year, there are 12 payments that they do. So that's why we know we have to times the number of years by the number of times we compound it, which is 12. So we know it's 60, but we can actually just write 5 times the 12 and it'll calculate 60. Remember to press tab to move around, to press the tab button. I, which is the rate, 5.5%. Present value, well, we put in 500,000, didn't we? So Lars put in 500,000 and just notice my mistake there. 500,000 is money out of his pocket, so it should be negative 500,000. And then also payments is negative $500 per month, because that's coming out of his pocket and putting into the bank account. And then PPY, always make sure to fix this before you get the answer of the future value. So PPY we knew was 12 times a year is the number of payments they make. And CPY is obviously interest that's calculated. Often it's the same. Okay, so we're going to go back to our future value. So this predicts after 60 payments, that's what the N tells us. After 60 payments, how much would that be if we follow this process where I put in $500 at PPY, which is payments 12 times a year for 5 years, which means 60 payments overall. What is the value if I started off with 500,000 at a rate of 5.5? Okay, so I'm going to press enter, and we can see that we now get 60. Whoa, what is that? That's $692,292 and essentially 30 cents, isn't it? So I'm just going to screenshot this so that we can put it into our sheet over here. So there we go. This is using Finance Solver. So just be careful with the amount when you're doing this, just making sure that these two are negative, or depends on whether the money's coming out of your pocket or whether it goes into the bank, or whether the bank is giving you money and you've got more in your account, okay, into your pocket. Then that's where it matters most, whether your calculation is going to be correct or not. So really, the answer is after 5 years. Okay, after 5 years, you can say that Lars' investment will now be worth. So Lars put in $500,000 to begin with, and after 5 years, Lars' investment will be now worth what is it? $692,000 and $292 and rounding it off to the nearest cent. You can see it's 29, but with the 7 that rounds up to 9 and hence rounds up to 2, so it is now 30 cents. Okay, so that is your answer there for the future value after 5 years in this particular example using Finance Solver. And remember, in the previous example, you are doing a recursive formula on your CAS instead.